This is the walkthrough video for PCTC 2024-2025, round 2, question 9, borderland. So in this question we're given this representation of zeros and ones, and essentially there's an island that's made of the ones, and the island may have internal lakes, and the problem is we need to identify what the external border length of the land is. And this is a little tricky, like you need to do some thinking. And basically the solution I'm going to do is a BFS, or a breadth first search. And this is also known as a flood fill. And thinking about it as a flood fill is probably a bit easier for this problem. So what I'm going to do is I'm going to go to the top left corner, because we know based on the constraints that the top left corner will always be water. So I'm going to go in the top left corner, then do a flood fill to fill out basically every external piece of water and until we discovered it all. And every time we hit a piece of land, we're going to add that to our running total. And by doing it this way, we essentially ensure that we only keep track of the external border. Because if, for example, we did a flood fill on the island, on a 1, for example, then we're going to hit the external as well as the internal border, which we don't want. So by only doing the flood fill on the very first cell, we ensure that we only ever hit the external border. But anyway, let's take in our input. So let's call this a grid, and that's going to be the list of an input for I in range 10 times. So this is going to be a nested list with a list of 10 lists, where each of the individual lists just contains the row as a list. And since this is going to be a BFS or flood fill, we want to import the library, or import the command called deck. So you import this from the library called collections. From collections, import deck. And deck is just double-ended queue. It's just the way that we deal with BFSs, because it's a bit more efficient. This is how we create our queue. So the queue itself is going to be, let's call it queue. The queue itself is going to be a deck, and the deck is going to be a list. So we're basically taking this list and we're converting it to a deck. Now the list contains a state, or a series of states. Now initially it only contains one state, and the one state it contains is where we currently are, which is called a 0, 0. And that's probably all we need to contain, yeah. So our state just contains our current location, and then we'll keep adding more and more locations to this list, but actually since we converted to a deck, it's actually a deck. So that may be a bit confusing to you if you're new to this, but essentially just think of this as the list that we're kind of dealing with, and we just wrap it around with a deck command to convert it to a deck, which just makes everything a bit more efficient, but in practice it's very similar to a list. Okay, so now we also need a running total. So let's say total is equal to 0, and we also need a visited set to ensure that we don't visit the same coordinates multiple times, because that's just going to waste time, and we can't afford to waste time. Okay, so now let's say while queue. So whilst there are still states to check in queue, let's extract the states. Let's extract the x and the y coordinates from queue by doing q.popleft, which is a command that you can use on decks, and it's a command that basically just pops the deck, but instead of popping it from the right like you usually do for a list, it pops it to the left, hence pop left. And the first thing we should probably do is check to see if we've already visited this place. So if x, y in visited, then we've already visited it. So let's just continue the while loop and skip back to the start. Otherwise, let's add it to visited. So visited.add x, y. Awesome. Now we should also check to see where we can move from our current position. Where can we move? So we can move in the 4 directions: up, down, left, and right. So first, let's check up. So, well, so let's check up. So new x is going to be equal to, well, new y is going to be equal to y minus 1, because that's what going up in our grid is going to be as. And now we need to ensure that this is within our bounds. So if new y is still bigger than or equal to 0, but also still smaller than the length of the grid, then we are within bounds. Otherwise we're not within bounds, so we can just kind of ignore this. So if we are within bounds, then we can actually do the next step. And the next step is going to be checking to see whether this new coordinate we're about to visit is a 1 or a 0. So let's do that now. So we can say if grid, and we first want to reference the new y, then we want to reference the x. So if grid new y x is equal to a 1, then that means we've hit an island. So we don't want to add this to our queue, because we can't flood onto the island. We're doing a flood fill, or BFS, on only the ocean, so the zeros. So if it's a 1, well, what that does mean is we can essentially add that to total, because that means we've just hit a border between the ocean and the land, which is, you know, the whole goal. Like, we want to find the external border. Yeah. So if it is a 1, that's what we do. If it isn't a 1, that means it's a 0, of course. And if it's a 0, that means we want to move there and explore that region. So to explore that region, we just add this to our queue using the queue.append. And what are we adding? Well, the new state we're adding is just the new position. And the new position is the x coordinate, which is the same as before, as well as the new y coordinate that we've just created. And this is kind of fundamentally the same piece of code that we want to run 4 times. So 4 times in all the 4 directions. So let's do that again. Let's say new y is equal to y plus 1 this time. Again, we have the same bounds. All this is exactly the same. Lovely. Now I want to do the same thing, but for x. So let's say new x is equal to x minus 1. We need to make sure that everything's within bounds. And the bound this time for x is that. It's the length of each row of the grid, not the grid itself. Now in reality, since we know the grid is actually just a 10 by 10 grid, then we can just like hard code the number 10 in here. You know what? Yeah, let's do that. That's probably easier. If you're writing more generalized code, then you wouldn't want to hard code the number 10 because the length could vary. Awesome. And let's just ensure that we have all the correct variables being used here. So we want new x to be sent and y should be the old y. Now do that all again, copy paste that. And then so minusing 1 will add 1. So this is a little bit clunky, admittedly, but I mean, it's not too bad, right? It's just kind of the same thing 4 times. And that should actually be the solution, right? So that means once we run out of places to explore, so once visited is empty, once queue is empty, we run out of places to explore, and so the while loop will automatically end. And that means right at the end of our code, outside the while loop, we can print the total that we've collected so far. Full score. Yeah, so this is like not an easy problem, especially if you haven't come across a BFS before. If you have used BFSs before, this is probably relatively simple, maybe a couple of insights you needed. But if you've never come across a BFS, a breadth first search, I would recommend Googling what that is, breadth first search, and kind of learning how to implement it. I actually have a video on my channel about how to implement this, so you can watch that. And once you kind of understand more about how breadth first search works and what it is, then solutions or problems like this become a lot simpler to solve. And it's kind of a game of identifying, what am I breadth first searching? What am I flood filling? Well, you're flood filling the outside ocean. Well, where do I know where the outside ocean starts? Well, thanks to the constraint, it starts in the top left corner, or really any corner, or really any edge. So you can start in any edge cell. You can do a flood fill, and every time you encounter a piece of land, you've therefore hit a boundary between land and ocean. Therefore, you can add that to your total border, which is going to be your final answer. So it's a bit confusing, but hopefully I've made it clear enough. And again, this bit where we've kind of had 4 chunks of code repeated at the same time, the same thing. You can kind of write this in sleeker ways. I think this is just the most obvious way to think about it, but there are definitely sleeker and better ways, which might be a fun challenge for you to find.